Hello students. Before going to the elimination reactions and substitution reactions, so we will discuss about the types of the solvents. Okay. So types of solvents used in organic chemistry. Types of solvents used in organic chemistry or reactions. Okay. So in this organic reactions majorly, so solvents are classified into two categories. Solvents classified into two categories. One is polar solvents, non-polar solvents. Okay, polar solvents, non-polar solvents. So again, these polar solvents are classified into two categories. One is polar protic, polar protic. Another one is polar aprotic. These are the types of the solvents: polar, non-polar, polar. Again, classified into polar protic. Another one is the polar aprotic solvents. So first one, polar. So polar solvent means polar solvent. So very simple only. The solvents whose molecule possess permanent dipole moment. Permanent dipole moment. So the solvents whose molecule possess permanent dipole moment are called polar solvents. Next, second one is non-polar. Non-polar. So what is the meaning of here? Non-polar solvent. So in this non-polar solvent means, so the solvents whose molecule possess no net dipole moment. Okay, simply no net dipole moment. Okay, here solvents comparison in between. Solvents whose molecule here possess permanent dipole moment, but in non-polar case, the solvents whose molecule possess no dipole moment. So those are called non-polar solvents. So generally we will discuss about the polar, non-polar. In these two, polar again classified into polar protic and polar aprotic conditions. So in this first one, we will discuss polar solvent protics. Polar protic solvents. So what are the conditions for the polar protic solvents? So this polar protic means these are also forms permanent dipole moment. So these are called polar. The protic also polar in nature. And second condition, it contains it contains acidic hydrogen. Acidic hydrogen. Second condition. Next, third condition in this positive poles must be hydrogen. Positive pole is hydrogen atom. Okay, positive pole is hydrogen atom. Then what happens here? It solvates both cation and anion. Another condition, it solvate both cation and anion. Okay, so these are the conditions for the polar protic. And next we will discuss now examples of this polar protic solvents. So what are the examples for the polar protic solvents? So H2O, ammonia, NH3 molecule. Next, methyl alcohol, CH3OH. Next, formic acid, HCOOH, formic acid. Next, ethylene glycol, ethylene glycol. Next, just now we discussed alcohols means here ethanol also will come. That is ethyl alcohol, C2H5OH. Methyl alcohol, ethyl alcohol. Both are the polar protic solvents only. Next, tertiary butyl alcohol, tertiary butyl alcohol. Next, acetic acid, CH3COOH, acetic acid. So these all are the examples of the polar protic solvents. So these all are depends on the dielectric constant values. So the dielectric constant value always this one is very high. Water molecule is very high. So the dielectric constant value nearly 79. So if it is a very high means it acts as a more polar protic in nature. So these are the examples of the polar protic solvents. So next, another one we will discuss polar aprotic solvent. So what are the conditions for the aprotic also? Next, polar aprotic solvents. Aprotic solvents. So in this also, the first condition is polar. Aprotic also polar in nature. Next, second condition, they do not contain, they do not contain acidic hydrogen, acidic hydrogen. Before case that one has acidic hydrogen, but this one they do not contain. Next, third condition. So in this third condition, so positive pole is bulky. Positive pole is a bulky, or we can add this one crowded. Okay, bulky group or the crowded group only positive pole develops. Next, in the before case, we discussed that when both solvents, the both cation and anions, but in this case, the solvent, which one here? This polar aprotic solvent the cations only better than the anions. Okay, so now here's this one solvent cations better than anions. Okay, so these are the conditions for which one polar aprotic solvents. So in this polar aprotic solvents, so now we will discuss the examples. So what are the examples? So belongs to these polar aprotic solvents. Okay, first one DMSO. The name of the compound is dimethyl sulfoxide. Dimethyl sulfoxide. So DMSO, dimethyl sulfoxide, generally that formula CH3. Okay, here S only will come, sulfoxide, S double bond O, CH3. So this one is the dimethyl sulfoxide. So how this molecule is polar aprotic means now S double bond group oxygen has a partially negative, sulfur get the partially positive. Now observe in this oxygen here negative, sulfur is positive. So polarity developed in between the sulfur and oxygen, but there is no hydrogen atom on the group. So it is not a acidic hydrogen. So bulk group only get the positive charge. Here this sulfur only here got positive charge. Okay, this is DMSO. Next, another example. DMSO already completed. DMF next. DMF. So that name dimethyl formamide. Okay, dimethyl formamide. So in this dimethyl formamide structure, so generally we know that H C double bond O N. It is a pharma group. It is amide group. How many methyl groups on the nitrogen now? Two. So take here one CH3. Here also one more CH3. So this kind of representation is called dimethyl. It is a one methyl group. This is another methyl group. Dimethyl. It is called formamide. Now here also now oxygen is more electronegative. This one get the partially negative. Carbon get the partially positive. So before case in solvents, hydrogen only got the positive charge. But in this case, carbon in the before case sulfur. So these are the bulky or the crowded groups only got here positive charge. So DMF is an example of which one? Polar aprotic solvent. Next, another example, acetonitrile. So acetonitrile is another example. The formula is CH3C triple bond N. So CH3C triple bond N. In this given condition also this one based on the electronegativity difference. The electronegativity difference nitrogen here get the partially negative, carbon get the partially positive. So this one is the acetonitrile group. Acetonitrile. Next, another one is acetone molecule. Another example is acetone. So generally the formula is CH3, C double bond O, CH3. CH3, C double bond O, CH3 is the acetone molecule. So in this acetone molecule, generally if you observe this, now oxygen get the partially negative, carbon get the partially positive. Here polarity developed, but there is no acidic hydrogen on this group. Now next another molecule THF. The name of this one is called tetrahydrofuran. Tetrahydrofuran. So tetrahydrofuran is representation. This one is the tetrahydrofuran. So this tetrahydrofuran is also acts as a polar aprotic solvent. This group withdraws electrons from the adjacent carbon only. Now oxygen get the partially negative charge. This one get the partially negative. These groups get the partially positive charges adjacent groups. So now this total molecule acts as a polar aprotic solvent. Next, another one is ethyl acetate molecule. Ethyl acetate molecule. So in this ethyl acetate, so how to write that compound? CH3 C double bond O ethyl group. This one is called ethyl acetate molecule. In this ethyl acetate molecule, again the polarity develops in, it is carbonyl, carbon, here positive. Here only charge develops. It is a polar molecule. The next diethyl ether. Another example is diethyl ether. So C2H5O C2H5. Same like this ether only. This ether is also act as a solvent. So these two are the solvent molecules. So oxygen get the partially negative, that adjacent groups get the partially positive charges. Negative, they're partially positive of carbon atoms. Okay, carbon atoms only. Now, here carbon get the partially positive. So these are the polar aprotic solvents. These are very, very important. The polar aprotic solvents. So next, another one is non-polar solvent examples. Non-polar. So what are the examples here? Carbon disulfide. So this representation is CS2. So CS2 molecule is non-polar solvent. So due to that, electronegativity difference is mostly equal for carbon and sulfur. Okay, that's why here there is no polarity developed. Next, another one. So many number of examples also there in this. Next, toluene, benzene. Next, another one is carbon tetrachloride. It is CCl4. Next, CHCl3. It is chloroform or trichloromethane. Trichloro, carbon tetrachloride, carbon trichloro. It is chloroform molecule. And CH2Cl, dichloromethane, also example of non-polar solvent. Next, hexane. Next, heptane. So these all are the examples of etc. These all are the examples of non-polar solvents. Okay. So these are the totally polar, non-polar conditions. Polar again classified into two: polar aprotic and polar aprotic conditions. Okay, students. Next video. In next video, we will discuss elimination reactions. Thank you.